Hi there, welcome back. So in this particular video, now that you know how to count SigFigs and identify SigFigs in a measurement or in a given value, now we're going to take a look at doing calculations with SigFigs. So you probably want a calculator if you want to practice along. Definitely makes it a little bit easier to kind of practice and get used to kind of seeing what's going on. So the key idea here, the thing that's really important with dealing with SigFigs is this idea that whatever, getting my pen right here, whatever calculations that you do, and we do calculations all the time with physics stuff, right? That your answer that you are reporting, your calculated values, cannot be more precise or appear to be more precise than the original values, the original measurements that you put in. Now, your calculator doesn't know anything about SigFigs. I shouldn't say that. You know, some of the modern graphing calculators actually do know a little bit about it, but typically they don't. And so your calculators, when it does multiplication and division, it's going to carry it out to its mathematical end until it fills the display or until it gets to the, where there's no remainder, whatever's going on. But just because that answer is calculatable doesn't mean that it matches what's really happening in the real world. So we need to make sure that as we report our answers to calculations, that we are rounding them appropriately to match the precision of the measurements. And the typical rule is whatever the worst measurement that's going in, that's what's going to limit the value or the SigFigs of our calculations. So if we've got one like excellently precise value and then one like really estimated value, that means our answer has to be really kind of consistent with this like garbagey estimated value. You can't just go like ultra precise because one of your piece of the data is precise. You got to go with the garbage. And I know that sounds weird, but that's kind of an honesty sort of thing in terms of reporting calculated values. So again, that's kind of what we're talking about in here is that, again, your calculator is going to give you too many digits almost always. And you need to make sure that your reported answer is matching the horrible quality of your data that's going in. So how do we do that? Okay, let me move forward here and give some examples of what this looks like. Now, there's two different rules, two different general rules. One of them applies to multiplication division, and then one of them applies to typically addition and subtraction. And then how do we apply them to like combo problems? So with multiplication and division, the rule is you go with the least number of SigFigs. You look at your original values that are given to you. So like in here, I would look at my original values, these numbers. And then I would round my answer to match the worst of them. The one with the least number of SigFigs is how I round my problem. Keep in mind, this is just a little side note as you guys are doing conversions. Conversions are not considered to be to limit SigFigs. So when we say that 12 inches equals a foot, it's actually exactly 12.00000 inches equals a foot. We just tend to write it as 12 inches equals a foot. So you don't have to limit your answers based on conversions. You're only limiting your answers based on measurements, and that's the important part. So if you take a look at this, when you do your calculation on this, if you do 38.65 times 105.93, you get this value. This is your calculator answer that you get. It's way too precise. This answer right here, this measurement here had 4 SigFigs to it, right? All non-zeros. This answer here had 5 SigFigs in it, right? 4 SigFigs, 5 SigFigs. This calculator answer looks like it has 8. All of a sudden it went from being, decent precision to like this outstanding level of precision. And there's no way that happens. That's a calculator artifact. So you round your answer to match the least precise or the least number of SigFigs that's in your original measurements. That means I need to go with 4 SigFigs in my final answer. So I need to make sure that I report this so that it only has 4. So I'd start at the beginning, 1, 2, 3, 4. So there's my 4th digit right there. And I'm going to kind of look at what's after this. And do I round up or round down? It really is that you know the rules of rounding. So I would literally just say, okay, my final answer here should be 4094. If I did that correctly. You could put the decimal place there or not. It doesn't actually affect the number of SigFigs, but that would be an answer with 4 SigFigs to it. You drop off all the rest of this stuff. Again, it's not about decimal places. It's about total SigFigs. And this is an artifact of the way that multiplication and division work as functions. It's a math thing. Trust me on this one. So, all right, let's take a look at our second example. You should be able to kind of play along, right? Try it on your own. So take a look at our original values, 12.34 times 53, and we get 654.02. Well, if you take a look at this one right here has 4 sig figs, right? 1, 2, 3, 4. This one has 2 sig figs, 2 SF. So I need to make sure that my answer here matches this. It needs to only have 2 sig figs, not the 5 that the calculator provide for you. So 2 sig figs, start at the beginning. There's number 1. There's number 2. So now I kind of need to look at what's going on after here. So it's 6, 5 are my 2 significant digits. The 4 is going to round down, right? You're going to kind of drop that off. But you can't just write it like this. 65 and 654 are not the same thing. You guys know that. Which would you rather have? $65 or $650, right? This is what a placeholder 0 does. This is where placeholders come from. So we put this, that's a placeholder 0, right? 650 only has 2 sig figs because there's no decimal place here. That's a placeholder 0. That's why that's there, so that we now know it's 650. Don't write 650 point because that makes it 3 sig figs. This is our final answer, 650. Okay, bottom one, this is with scientific notation, so make sure you know how to use scientific notation in your calculator. Remember, you're looking for the little button that says EE. You can kind of see it on there. Not the x to the minus 1, but the EE that's above it. Some calculators have it as an EXP button down here, like if it's a Casio has that one. But if you're not sure, make sure to ask me at some point in time and I can show you. So 2.1 times 10 to the third plus 1.78 times 10 to the fifth. Oh, sorry, divided by 1.78 times 10 to the fifth gives us this value. Okay, again, crazy long value, especially in division, right? Calculators seem to be very overly enthusiastic, go lots of extra decimal places. So let's take a look. Okay, scientific notation is nice because anything that's written in scientific notation is significant. So this one has 2 sig figs. By the way, the exponents right here, that's what takes care of your placeholder zeros. That's what those are for. Okay, this one right here, 1.78. This has 3 sig figs. So 2 sig figs and 3 sig figs. Again, I have to go with my worst value, which is 2 sig figs. So now I got to look at my answer and figure out how to round this to 2 sig figs. Okay, so now 2 sig figs. Starting at the beginning, remember these don't count. Leader zeros never count. They are placeholder zeros, just like the zeros at the end of numbers. So those don't count. So there's our first sig fig. There's our second sig fig. Now we've got 2. That's all we got. So now I want to kind of take a look at what comes after that second sig fig. Well, that's a 7, 9. That's going to round it up. So I would write my answer as 0.012 would be a correct value with 2 sig figs. I could also write it in scientific notation, 1.2 times 10 to the minus 123, right? All works. Also has 2 sig figs. So these are both correct. It doesn't matter. They're interchangeable numbers as far as physics is concerned. So there you go. Okay, multiplication and division, you look at your original measurements and you round your answer to the correct number, the least number of sig figs that appeared in your original measurements. Okay, moving forward into addition and subtraction. Addition and subtraction is a little bit different. The way that addition and subtraction works. It's a different rule slightly because of the way addition and subtraction works. When you multiply and divide, you don't actually have to have the same units. That's how we get compound units like area and volume and density, speeds, right? Miles per hour. When you're dividing and multiplying, you don't need to have the same units. But when you're adding and subtracting, they must be in the same unit. Therefore, placeholder zeros have a different role here. So the way that this works is with addition and subtraction, you can actually just focus on decimal places because the decimal places is going to give you the precision in addition and subtraction. It actually is what helps you get rid of the unneeded placeholder zeros that would not be significant. So you got to be a little bit careful with addition and subtraction. It's a different rule. So if you take a look at this one, 4.231 minus 3.51, but for subtracting these, here's our calculated answer, 0.702 or 0.721. So now to count this, we're going to look here. This has got 1, 2, 3 decimal places. This one here has 2 decimal places. That means that this tenths hundredths spot is our least precise value. So therefore, we have to round this one to 2 spots to our least precise value, our least precise digit, which is 0.72. 2 decimal places. In this case, it's also 2 sig figs. Your number of decimal places in your sig figs are not the same, right? This has got 3 decimal places, but 4 sig figs. This has got 3 sig figs and 2 decimal places. So this one has now 2 decimal places and 2 sig figs. 2 decimal places as well. All right. Second one, again, follow along. 12.34. This one is precise down to the hundredths place. And this one is 53, which is precise down to the ones place. So when we have our answer like this, that means our answer can only be precise to the least precise of our numbers. Our least precise digit is our ones place. That means this is all we've got to work with. Our final answer here would be rounded to 65. Again, 0 decimal places, but also 2 sig figs. I know it's weird. Our least precise value was the precise to the ones, so our answer has to be to the ones. Okay, so here's 2 more. Least number of decimal places, or the least precise placeholder, if you want to call it that way. So here's 1800 and 291. Okay, 1800 plus 291 gives you 2091. All right, so where is the least precise digit? This is precise to the ones place. This is precise to the hundreds place. The least number of decimal places. I know it's kind of weird to think about hundreds as being a decimal place, but that means that we need to round it here to the least precise number of values at the hundreds place. So this would actually be recorded as 2100. Those are placeholder zeros. This is precise to the 100s place. It looks really weird. 2100 and 1800, same level of precision. So again, now this one also has 2 sig figs. So there you go. Addition and subtraction is a little bit different. You're looking at decimal places. And this gets really awkward with scientific notation. And that's why I didn't do one for here. We're good with what we're doing at this particular spot. We're not going to do that super often. So there we go. Okay, combining them. Don't forget PEMDAS is a thing. You will have some cases where you have to do addition, subtraction, multiplication, division in the same thing. So don't forget PEMDAS. Don't forget PEMDAS. You always do parentheses first. Then you do exponents. Then you do multiply and divide. Then you do add and subtract. As you do these problems, you keep track of your sig figs as you go, but you only round at the very last stop. Don't serially round. And that's an important thing as we get into multi-step problems. You don't round and then round and then round again. That's going to compound errors. So make sure you're keeping subtotals in your calculator, and then only round your very final answer. So with this one, again, PEMDAS applies. So we're going to take a look here. We have to do our parentheses first, and then we multiply. So parentheses first, and then we multiply. So 12.3 plus, I got to get my calculator on 12, clear. 12.3 plus 0.06 gives us a value here of 12.36. Now, what's our least significant digit? Our least significant digit is here, right? It would be like 12.4. That's our least significant digit. Times 53.44. So 12.36 times 53.44. Okay. This gives us this answer right here, this 5501584. Okay, but now we got to take a look at our values. This one here had 3 sig figs. Again, this was our least precise value from the addition problem. This one here had 4 sig figs. So that means now we need to answer this in 4 sig figs. Oh, sorry, the 3 sig figs, right? The least precise. So if I take a look at this, 1, 2, there's our third spot. This would round it up. So our final answer here would be 661. I know it's weird. I know. We don't do a lot of this, but I just want to make sure we're kind of clear on what we're doing and why. Okay, the bottom one. PEMDAS again. Okay, so PEMDAS means we do multiplication and division first, and then we do the addition and subtraction. So that means this happens first. Again, parentheses, exponents, multiply, divide, then add, subtract. We actually have to do this part first before we do this part. 14.021 divided by 18.9 gives us a sub value of 0.74185 and some change, right? There's more decimal places to that. So how many sig figs do we have here? Again, we're dividing, so I'm using my SigFigs rule. This is 3 sig figs. This one here has 5 sig figs, so 3, 1, 2, 3 sig figs is my only ones that I've got. And then I do 68.7 sorry, I got to do this in my calculator, right? 68.7 minus 0.74185 and whatever else was on there. And I get this crazy thing, right? The 79.185. Okay, so now SigFigs. If I do 68.7 minus this thing with 3 SigFigs, what's our least number of decimal places? Okay, again, now we're doing a subtraction problem last, so what's our least number of decimal places? So this has 1 decimal place. This one had 1, 2, 3 decimal places. So again, we're going to round our final answer to 1 decimal place. I know it's weird. It's hard to go back and forth. So that means here is our least significant value that we're going to use in this one. So it's going to be, oh man, it's going to round up, 68.0 is our final answer. Okay, so there you go. So this is how you do SigFigs in calculations. Multiplication division rule is about SigFigs. The addition subtraction rule is about decimal places. And then PEMDAS, or both of them, is about PEMDAS and what order you do it in. So good luck with that. Hang in there. We use the multiplication division one a lot. We don't use the addition subtraction one as much. So you'll see. And I hope that helped make it clear as mud. See you guys. Bye.